All right, guys, Mrs. Meyer here, and we are about to start our very first lesson, Lesson 1-1, one variable equations. Okay, so the goal of today's lesson is to create an equation in one variable, and then we're going to be able to solve that equation. So we're going to take real-world context and transform it into a math equation so we can solve. So what you're going to need for this lesson is a guided note sheet that we have made for you. We are not doing this lesson from the book. And then pen or pencil, and it's probably helpful if you have a calculator nearby just to do some quick calculations. So there are our targets again. We're going to create an equation in one variable from a real-world context and then actually solve it. So let's start with this first example, example A. So example A talks about Susan. Susan makes and sells purses. The purses cost her $12 each to make, and she's going to sell them for $25. This Saturday, she is renting a booth at a craft fair for $60. So what we're going to do is write an equation that can be used to find the number of purses Susan must sell to make a profit of $250 at the fair. So that's her goal for the day, $250. So let's start by kind of highlighting the key concepts here, like what do we actually need to pull from those sentences to actually write on our equation. So right away I see $12 each. So each usually represents like a multiplication, so some kind of operation we're going to do. Okay, so I know we're going to have 12 times the many purses, and then she sells them for $25. So we're going to probably need that also. And then we also have this extra expense of the $60 to rent the booth at the fair. Okay, so what's our end goal for Susan today? Susan wants to make a profit of $250. So that's kind of what we want it to end up in at the end. So let's start by defining our variables. We want to make sure we know what we're solving for. So right here it says write an equation to find the number of purses. So that has to be our x. Okay, so I'm just going to put that over here. Okay, so now I know what I'm solving for. I can translate this into a math expression. So let's think of it first in terms of real world ideas here. So in the end, we want a profit. That's the goal of this equation. We want it to end up giving us a profit at the end. Well, anytime you sell something, how do you make a profit, right? You take the money that it costs that you're going to sell something for, right? And then you always subtract the money that it costs to make it. So let's call that like your expenses. And that's how you get a product. So you sell something for X amount of dollars, you take away your expenses, the money that is left over is your profit at the end of the day. So now let's put in our numbers from our problem, and then it'll make it a lot easier to set up. So our profit, we know, is she wants it to be $250. Okay, so how much is she selling the purses for? She's selling them for $25 for each purse. So I'm going to do 25x. Okay, and then I'm going to subtract away all my expenses. So it costs her, probably materials and everything, $12 a purse. And then we also have to take away the expense of the booth. Okay, so we have our money it costs to make the purse and our expenses for the booth. Subtract that from how much we're selling it for. That should give us our profit. So I'm just going to go ahead and clean this up really quick. I'm going to combine like terms here. So 25x minus 12x is going to give me 13x. Just going to bring down that minus 60. Set it equal to our profit. Now I just kind of rearranged it for my own personal preference there. But there we go. There's our equation. So now in number 2, what they want us to do is actually solve this equation. So this equation down here. So maybe I'll just rewrite it. 13x minus 60 is equal to 250. Okay. Now this is just a 2-step equation. I'm sure you guys can go ahead and solve this. I'm going to just do the work really quick. If I add 60 to both sides, that's going to give me 310. So then to get x by itself, I'm just dividing. Now it's not going to divide nice. We're going to get this decimal, 23.8. So what that tells me is she has to make 23.8 purses in order to hit that profit goal. Well, I can't really have 0.8 of a purse. So I'm going to actually have to round this up, right? Because 23 wouldn't be enough for the profit. So we're going to have to round up our thing here to 24. 24 purses. Make sure you interpret your answer. If you're solving for X, you know actually what you're solving for. That's why I knew this decimal doesn't really make sense. That's why we rounded our answer. Okay. So then here's just a little progress check question. If Susan sells 20 purses at the fair, will she meet her goal? Why or why not? So why don't you pause the video right here, answer this question quickly, go back to the work that we did up here, probably will help you a lot, but give it a quick pause, answer this question, and then come back for the answer. Okay, so we already just learned that she needs to sell 24 purses to meet her goal. So the answer for this is no. She needs to sell a minimum of 24 purses. 20 purses would not hit her profit goal. She'll make some money, but not the goal that she wants. Okay, all right, let's do another example together. Here we go, example B. This one's about Nick and Sally. They plan to buy a pizza. The pizza costs $15. Okay, they decide to split the cost based on how much pizza each person eats. Okay, Sally eats 2/3 the amount that Nick eats. So Nick's going to eat more pizza. Sally doesn't want to pay for the whole pizza because she doesn't eat as much as Nick. So she says if Nick eats more, he should pay more. So that's kind of our key amounts here. So let's highlight some key ideas. Okay, all the numbers here. Pizza costs $15. And then we probably need this sentence. Sally eats 2/3 the amount that Nick eats. So now we got to set up our variable, so our X, whatever we're calling it. I'm just going to call it X just to keep it simple. So who are we basing the equation off of? Are we basing it off of Sally or are we basing it off of Nick? So read this sentence again really carefully. Sally eats 2/3 the amount that Nick eats. So we're basing everything off of Nick. So that's what I'm going to call X. X is the amount of pizza that Nick eats. Okay. So again, I'm going to think of this as the real world. So we have to figure out how much each person is going to pay. So let's say we have how much Nick should pay plus the amount that Sally's going to pay. That should equal our total cost, right? So let's think of it like this. We already said how much Nick eats is going to be our X. So now let's translate this. We'll call that X. We know we have to total $15. That's how much the pizza cost. So now it says Sally eats 2/3 the amount that Nick eats. Well, if Nick is X, 2/3 of that would just be 2/3 X. And there we go. We did the hard part. We set it up. Now, since we probably want, we could combine those like terms. Think of that as a little 1 in front. So if you have 1 plus 2/3, you have 1 and 2/3 X. And that's going to equal 15. Okay, there's our equation. So in number 5, they want you to solve the equation. So let's see what we get here. Now you can turn this into an improper fraction if you want. I'm just going to leave it the way it is and just use my calculator. I don't need to work more than I should. So basically what we have to do is we have to divide by 1 and 2/3. Okay, not too bad. So let's just go back to here really quick. I have 1 and 2/3 X equal to 15. So if I divide out that fraction on both sides, that should solve the problem for me. So let's just use our calculator. Okay, so I have 15 divided by. Now, if you hit alpha y equals, it gives you this kind of menu. So this is for a mixed number. So divided by 1 and 2/3. There's our X. X is 9. Okay, so remember, X is how much Nick's going to pay because that's how much Nick eats. So in this case, if I interpret my answer, Nick's going to pay $9. So what does that leave for Sally? Okay, well, remember the whole pizza costs $15. So if Nick pays 9 of that, that means Sally has the leftover 6. And there we go. All right, we just have one more that we're going to do really fast, and then you guys are going to try some on your own. So I have Marco mowed 8 of his neighbor's lawn. He charged $22 for a short driveway and $37 for a long driveway. So let's highlight some stuff again. So $22 for a short driveway, $37 for a long driveway. Marco made $266 in one day. That's probably important, so I'm going to highlight it. Write an equation that can be used to find the number of lawns he mowed when X of the driveways are short. Okay, now I color coded that so you could see we have X driveways are short, $22 was for a short driveway. Now this one's going to be a little trickier because we only have one variable that we're using. Again, I'm probably going to call it X, okay? So remember, X is the short driveways. So if I think of it like this, well, I know if the short driveways cost $22 each, so I can just go ahead and do this, 22x. Now in the end, I want it to equal our total money that he made, $266, right? So now I just have to figure out how do I relate the $37 he charges for long driveways. Now I can't just do 37x because x stands for the short driveways. So here's what we have to do and what makes this problem a little trickier. He said in the beginning that he did a total of 8 driveways in that day. Okay, so I need to figure out how to take, if I know, so say I know he does, I'm making this up, I know he does 5 driveways that are short. Well, that left over then would mean he has 3 driveways that he did are long. Or if he did 4 short driveways, he did 4 long driveways. So the total always has to add up to 8. Now in this case, he did X short driveways. So how do I figure out how to do a long one? And we kind of got to think about it a little different. We have to take the total driveways he did and subtract the short driveways. So it's similar to what I did with the numbers, but just a little different in terms of how we write it. So I know X are short. That means I have some long, so I take the total he did and subtract off the ones that are short. Okay. Now I'm going to have you guys go ahead and solve this problem. You got to do a little distributing, combining like terms. So go ahead and try this problem on your own, see what you get. So solve the equation and interpret your solution. Okay, so if you did it correctly, you should have got that X equals 2. So remember, X stood for the short driveways. So that means he mowed, so he did 2 short driveways. Well, what does that leave for long driveways then? If they did 8 total, well, 8 minus 2, that's 6. That means he mowed 6 lawns that have a long driveway. Okay, and there we go. All right, so the last 3 I'm going to have for you guys to try on your own. I'm going to give you the answers in the end, but I'm going to have you guys try them. So number 1, Alex paid $65 to rent a bike in the city. It costs $15 per hour to rent a bike. The additional fee for a helmet is $3 for the entire ride. How long did Alex ride for? So go ahead now and try to write the equation for that. Okay, so what you should have got was 15x, $15 per hour, plus the cost of the helmet. He only got the helmet once, so no variable there, just $3. And he paid a total of $65. So how long did he ride for? If you solve that equation, you should have got that he rode for 4 hours. Okay. I believe you get something like 4.13. So in order to get his $65, he could only ride for 4 hours. He can't go 5 hours. We wouldn't round it up because he doesn't have enough money for 5 hours. So that's why in this case, I rounded the answer down. Okay. Number 2, Dante is holding a local dance for the community. He pays $125 to rent the local firehouse for the evening. Remember, that's a one-time expense. He must also pay $3 for insurance for every guest at the party. If Dante charges $8 for entry to the dance, how many tickets must he sell to break even? So I want you to think about what it means to break even. Okay, so go ahead and try this problem. See if you can write the equation. Okay, so what it means to break even, that means that your expenses, how long does it take your expenses to equal your profits, or how much you're making? Okay, so if you followed that kind of idea, you should have got this equation. So it's $3 for insurance for each guest plus the money to rent the firehouse. Well, how long does that take to equal what he sells each ticket for? $8 per ticket. So how many does he have to sell to actually break even? 25 people have to come to this dance. So if the more people come, the more money he makes. If less than 25 people come, then he's not going to make any money. He's going to lose money. All right, last one. Pedro cleaned 7 of his neighbor's pools. He charged $10 for an above-ground pool and $18 for an in-ground pool. Write an expression that could be used to find the total amount that Marco charged when X of the pools are in-ground. Okay, now this one's just a multiple choice, so it's very similar to the one we did up here, okay, with Marco and his neighbor's lawns. So it's very similar to that. So think about what we did. Remember, X is your number of in-ground pools, so that should kind of help you eliminate some wrong answers. So see if you can figure out which one that is. A, B, C, or D. Okay, if you got it right, you should have been picking answer B. 18 for each in-ground pool, so 18x. So right away I knew these were out. Okay, and then it's just a matter of doing the $10 for the above ground pool, taking the total and minusing what you already know for the in-ground pools. All right, guys, that is the end of our first lesson, lesson 1-1. So writing one variable equations and then being able to solve those one variable equations when we are done with them. Okay. All right, I hope you had a good first lesson. See you next time for the 1-2.